Assalamualaikum warahmatullahi wabarakatuh, my dear friends. How are you? Welcome to my default physics channel. So in this video, my topic today is basis linear algebra. So now in physics, what are usage of basis linear algebra? In mathematics, a set B of vectors is a vector spaces V is called a basis. Basis if every element of V may be written in a unique way as a finite linear combination of elements of B. The coefficients of the linear combination are referred to as components or coordinates of the vector with respect to B. The elements of the basis are called basis vectors. Equivalently, a set B is the basis of its elements are linearly independent, and every element of B is a linear combination of elements of B. In other words, a basis is a linearly independent spanning set. A vector space can have several bases. However, all the bases have the same number of elements called dimension of the vector space. The article deals mainly with finite dimensional vector spaces. However, many of the principles are the valid infinite dimensional vector spaces. So now I will define the definition of basis vectors. A basis B of a vector space V over a field F, such as the real numbers R or a complex number C, is a linearly independent subset of V that spans V. This means that subject B of V is the basis if satisfies the two following conditions: linear independence for every finite subject V1, comma comma Vm bracket of B I if C1 V1 plus plus Cm Vm is equal 0 for some C1. Spanning property: for every vector V in V1 case, choose A1 in F and V1 Vn in B, that V is equal A1 V1 plus plus A and Vn. The scalars AI are called the coordinates of the vector V with respect to the basis B, and by the first property that they are uniquely determined. A vector space that has a finite basis is called finite dimensional. In the case, the finite subset can be taken as B itself to check for linear independence in the above definition. It is often conventional or even necessary to have an ordinary on the basis vectors. For example, when discussion orientation or when one considers the scalar coefficients of the vector with respect to the basis without referring explicitly to the basis elements. In the case, the ordering is necessary for associating each coefficient to the corresponding basis elements. This ordering can be done by numbering the basis elements in the order to emphasize that an order has been chosen. One speaks of an order basis, which is therefore not simply on structure set but a sequence and index family are similar. See double order basis and coordinates below. For example, the set R2 of the ordered parts pairs of real number is a vector space under the operations of component wise addition. A B plus C D is equal A B A plus C comma B plus D, and scalar multiplication where x is a real number are simply bases of this vector space consistent of the two vectors. E1 is equal 1, 0 and E2 is equal 0, 1. These vectors from the basis called the standard basis, because any vector V is equal A, B of R2 may be uniquely written as V is equal AE1 plus BE2. Any other pair of linearly independent vectors of R2 such as 1, 1 and -1, 2 forms also the basis of R2. Many More generally, if F is a field, the set Fn of n tuples of elements of F is a vector space. So similarly, define addition and scalar multiplication. Let ei is equal 0 com dot 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 com 0 com 1 com 0 dot 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 com 0. So friends, otherwise how is my topic? This is the basis of vectors in linear algebra. If you like this topic, so subscribe my channel, and now I am go to my another topic. Allah Hafiz, we will meet next video. Allah Hafiz.